Alrighty, welcome back to Fun Maths. Today we're looking at the normal approximation to the binomial distribution. And what we're looking at here are some graphics for binomial distributions for where the n value is 10, 20, 50 and 100. And also looking at the p-value being 0.2, 0.5 or 0.8. And what you can see, or what you should be able to see here, is that if you've got a small n value and p is close to 0 or it's close to 1, what can happen is that these distributions are skewed. So here you got a p-value or a low n value, and the p-value is close to 1. You can see it's skewed, the data. Likewise here it's close to 1, the p-value, it's skewed. Now, as you start getting a greater value of n, what you should notice is that the data becomes less skewed and it becomes very much like an approximation of that normal distribution. Yeah, and so we can use this to our advantage. Yeah, so let's have a look here. Now, it's essentially saying if you have a large enough n value, then we can use this approximation. But you're probably wondering, okay, well, what is an appropriately large value? So again, the approximation is generally better if you have a larger value of n, and you don't want p to be too close to 0 or 1. So here is the rule. It says if n is sufficiently large, the binomial random variable x will be approximately normally distributed with a mean of mu being equal to n times p and the standard deviation of sigma as follows here. It says one rule of thumb is that both np, so n times p, and n multiplied by 1 take away p must be greater than 5 for a satisfactory approximation. Yep. So again, it's easy enough to check these. We can multiply these and find out whether they're greater than 5 to get a desirable result. Alright, let's have a look at this example here. It says, a sample of 1,000 people from a certain city were asked to indicate whether or not they were in favour of the construction of a new freeway. It is known that 30% of people in this city are in favour of the new freeway. Cool. It says find the approximate probability that between 270 and 330 people in the sample were in favour of the new freeway. Alrighty, let's see what's going on here. So, needed to find that variable x being the number of people in the sample who are in favour of the freeway. Then you can assume that x is a binomial random variable with n being equal to 1,000, and the probability was 30%, so p is equal to 0.3. So we can run the calculation now for the standard deviation and also the mean. So here we can do n times p, easy enough, it's 300. For sigma here, we can run the calculation, square root of that, it stays, and you can just leave it as a square root of 210. Cool. So we have the mean and the standard deviation. Alrighty, so now we've got to find the values between 270 and 330 people in the sample. They were in favour of the new freeway. So we need to find the standard score, which is obviously going to be that data value, which is 270, take away that mean value divided by the standard deviation. We can do that for both 270 and 330. And then we've got the standard score. We can plug that into our normal distribution and find out what the probability is here. In this case, it is 0.9616. Thank you very much for listening up. Have a good day.